Hello and welcome to episode 144 of the HamCorp Training Manual. In this episode, we upgrade the space pumps, show off a side project I intend to work on soon, and find a better, more robust automation for the black hole compressor. We also craft the Antimatter forge, but construction and automation will be covered next episode. And we are back on the grind. Currently crafting up protomatter activation coils for the SASs. But I'm stuck on the protomatter step because laser source is too weak to run this recipe. So I've built all of these lasers with UEV laser source hatch, which means I can do up to UIV crafts, and protomatter is a UMV craft, so I need to upgrade all of the source hatches here. But it actually doesn't feel that expensive. I'm making 20 UIV million amp laser source hatches. That should be pretty good, and it's more parallels than before too because of the high amperage. But this will allow me to do the protomatter, and then this will be done. And then there's only 3 more parts. There's the actual controller block, there's the magnetic flux casing, and there's the gravity stabilization casing. As for infrastructure, everything in here is working quite well, but there are still some more multis that I need to scale up. The ones that are most apparent to me right now are the lathe. I have 1 lathe. The circuit assembly lines, I made a few between episodes. I've added 2 more quads to the optical line, but I haven't added anything to the bio line, so maybe I should do that too, and scale this one up. There's quite a lot of circuits that need to be made, so this is definitely not enough circuit assembly lines, but it's a start, I guess. And then, of course, space assembly is just terribly slow because it doesn't overclock, so I just need to spam more modules. And the space pumping module Mark II, which I did the scan for in the last episode, and I talked about it, but I never actually made it. Actually, I even made it, I just didn't finish the quest, so here. I even made 4 of them. So I could swap these out pretty easily at the space elevator. I'll probably do that right now. But first, of course, I need to redo this whole laser line. And by redo, I mean remove, because I'm just going to dedicate an LSC to each of these. Alright, let's see. The Mark I pumping module makes 64,000 xenon per second. And the Mark II, oh, it has a bunch more. Right. This thing can pump 4 different fluids at the same time. For now, I think I'm going to just set them all to xenon. So Planet 6, gas type 4, Planet 6, gas type 4. And as expected, this is just 4 times faster. That's pretty nice, but it's not a massive increase because this still doesn't overclock. So this is the most I'm going to get out of this. Once I get the Mark III pump though, that goes up from 4 parallels per recipe to 64 parallels per recipe. So this would become 16 times faster than it is right now. That's pretty good. But of course, the Mark III module is not accessible right now. I'm pretty close, to be fair, but I need white dwarf matter and molten eternity. And black dwarf matter. So I'm gonna have to wait until after the Eye of Harmony for this, which is, well, fair enough. This is pretty powerful. Now I do have 3 more space pumping modules Mark II, and honestly, I think xenon is my most used gas at the moment. It's just because recovering it is so slow. 256 buckets per second is not that fast. So I think I'm just going to dedicate 3 more Mark II pumps just to xenon. And I think that will bring me up to my limit with the Mark III motors. So if I want to add more pumps, I need to make better motors. Actually, wait, I can't even put down 3. These are already here. So I'm going to have to upgrade the motors as well. Here's a cute little design I whipped up for the lathes. There's only 16 for now. I'm doing the big brain wall share of sharing the middle part, so that's kind of satisfying, but I don't really know how many lathes I'm really going to need. Like, currently I make my screws in these for a lot of things, but there is a screw mold, so I could do it in the fluid shaper. And honestly, that's probably a better idea. That said, there's also some rods that have to be made in a lathe, like Certus quartz rods, I think lapis rods also maybe. And for those I will need lathes, but do I really need that many? I'm not sure. So I made 16, and I've left the top unfinished on purpose in case I decide I need more. But for now, this will be it. It's kind of cute, I think, as a corner piece. It's pretty cool. I kind of want to make more just for the decoration, but this is cool. By the way, I made my Mark IV motors. And I'm crafting up the magnetic flux casings. These are the last thing I need to finish off the antimatter forge. And I finally got my tau neutrino, which finishes off the fermion part of the standard model. So all the quarks and all the leptons. Still need some stuff for the bosons, but that's fine. That'll happen over time. And I guess this is a good time to say that I have started working on something interesting. This right here is a creative test world. We've got the Comet, the compact cyclotron. We have Mark V Fusion. We have the synchrotron from the Beamline, and the Forge of the Gods, and something new. This isn't actually a multi that is in the game, or even in development yet, but it's something I have started to work on myself. So this is going to be, whoops, forgot I'm in creative. This is going to be the Large Hadron Collider. This is my first pass at a design for it. And we don't actually have a collider in the game. I mean, there's the Comet, but boring. This is going to reuse some of the old beamline multis, like the Linac and the source chamber. And then we send the beams into the LHC, and that will create particle showers, which are collected, and then we can do stuff with them. That's the idea. And I've started putting together a design document for this, and I think during the Eye of Harmony waiting period, I'm going to start developing this, because this would be super cool to have. Mostly because I think the Comet is kind of boring. Like, this is supposed to be how you make particles, but it's so boring. You just put in hydrogen and you get particles. That's not really that interesting. But this could be cool. If I can bring this to completion and get it in the game, this would be pretty awesome. Ooh, and on the GTNH Discord, there is an area of interest that's been made for this. So if you would like to give me ideas or feedback, please put it there. Anyway, back to the game. Something else I want to refactor is my black hole automation, because right now it's a little jank. I'm not super happy with the item calculation that I have to do every time I make a new recipe. Adding the 450 liters of spacetime or whatever. That's, like, I don't need to do that anymore because spacetime is no longer that expensive to me. So I think I'm gonna try and find a new automation technique here. The stuff inside will probably be the same. This whole counting up to 80 to maximize the parallels, I think that part is fine, but the AE2 part of it will be a little different. Because I also made this automation before I had crafting input buffers, which I have now, so I should use them. I think that could simplify the design a lot. And also, now that spacetime's not an issue, I can just provide it and have it craft until it's done. And if I use 1 billion spacetime per tick, then so be it. It'll just be chalked up to being a skill issue on my part. Okay, here's a much better automation for the black hole. I wasn't able to get it to work with crafting input buffers, and I'm sort of convinced now that that's not really possible without open computers. But I did manage to do it with just the old setup, but cleaned up a lot. On the right here, I have my advanced stocking input bus and hatch set to circuit 21 for the neutronium compressor recipes. And I also have a fluid discretizer for any fluid-only recipes, so that this level emitter will emit a signal even if there's just fluids. This is not a fluid level emitter, which is important. The discretizer is going to treat the fluid as droplets, and because of that, this will trigger when there's fluid in the drive. On the left, I have an identical and mirrored setup, except it uses circuit 20. So this is for normal compressor recipes. Now, both these level emitters are set to 1, and to emit when levels are above or equal to limit. So when there's anything in these drives, the corresponding level emitter will emit a signal. And of course, like before, I have a receiving dual interface with an advanced blocking card, and a sending dual interface with the actual recipe with blocking mode on. Besides that, these two subnets are completely separate. And here I have 2 gates. The ground state, which is when there's nothing inside, is like this. So there are no signals coming from the level emitters, and these signals are connected to a NOR gate at the bottom and an OR gate at the top. So when there is no signal, this top signal is off, and this wireless transmitter set to 901 is off. When there's no signal, this NOR gate is on at the bottom, and so the wireless transmitter with frequency 900 is on. When either or both of these subnets receives inputs, essentially what happens is this switches, right? So 901 comes on and 900 turns off because this is a NOR gate and this one's an OR gate. Now, what do these signals do? This is the inside. As you can see, I've cleaned it up considerably. 900 is over here. This serves two purposes. One, it resets the counter, which you may remember from before. And two, it turns on this toggle bus. This toggle bus basically allows a stocking input bus to pull black hole collapsers. So this is to turn everything off at the end of a craft. Also, this is on a little subnet because using a toggle bus on the mainnet is not really recommended because it kind of has to recalculate the network, or at least that's what I've been told. So I put it on a subnet, and it's the subnet that gets toggled on and off. Frequency 901, there's a little repeater delay, which I'm playing around with. I'm not totally sure it's required, but this leads to a toggle bus on the other side, and this is where the black hole seed comes from. So this stocking input bus is turned on when 901 is on. So what happens is, inputs go in, that inverts these signals, meaning the collapser subnet is off and the seed subnet is turned on. This basically creates a black hole. And then, once the machine is actually running, I've got the black hole utility hatch set to pulse. So every second this pulses. And after 81 ticks, this counter goes all the way to the right and turns on frequency 81. That comes here to a stocking input bus. I should put this on a subnet, but it comes to a stocking input bus that has molten spacetime. So what happens is 81 seconds later, the molten spacetime is supplied to stabilize the black hole, and it's just supplied forever until the craft is done. If I run out of spacetime, that's too bad, but I don't think I'm going to run out of spacetime. Anyway, once the craft items are consumed and the signals switch again, this one gets turned off, so there's no more seeds available to the machine, and this gets turned on, so there's a black hole collapser, and it also resets the counter. I'm not sure why it didn't reset to 1 out of 81. I'm not sure why it's a 2 out of 81. Might need a little bit more testing, but honestly, this is fine too. I think I could probably increase this to 83 or something. It's probably fine. Close enough. But yeah, that should work. And I can just encode recipes as normal. I don't need to add any spacetime in here because that's all just handled by this toggle bus. Actually, with some more testing, I found that I require state cells. Because what happens is, because of these small batch sizes, the machine ends up waiting for the next set of inputs, as in this ME drive becomes empty, but not for long, only for 2 seconds or so before the next batch of ingredients comes in. What ended up happening was the level emitter would be on, and then it would turn off, but then it would turn on again pretty quickly. So it was kind of introducing signal noise in a sense, when it shouldn't really have turned off because it was too soon, and it turns on again before the black hole collapser can fully collapse the black hole. But it resets the timer. So what ended up happening was the timer got reset, but the black hole didn't get killed, which means the black hole became unstable and started voiding my items. To deal with that, I've added these 2 state cells. I mean, we can just look at one. The other one is just a mirror copy. So the state cell, the way it works, I don't know how the lock thing works, and I don't really care because it's not relevant for this automation, but a signal comes in and it starts the timer. You can set the timer to whatever you want. I set it to 10 seconds. I think maybe 6 or 7 seconds is probably sufficient, but to be safe, I made it 10. For that 10 seconds after the initial signal, this output signal will be on. And so long as the input signal is on, the timer doesn't tick. Once the input signal turns off, the timer starts to tick and the output still remains on. But then once the timer finally reaches the end, then it turns off. So in essence, what happens is, given how unstable this input signal can be, the state of the input signal must be the same for 10 seconds for this to change. In other words, this ME drive has to be empty for 10 whole seconds before the black hole is actually collapsed. And so far, this seems to work without a hitch. So I think this is properly automated. So it's a little complex, but I hope you're ready for something even more complex. Antimatter. Well, I'm sorry to disappoint, but I think the Antimatter Forge is going to have to wait until next episode. But I do still have a few more things to do this episode in preparation. This multi uses some antimatter to generate more antimatter. So to get my first antimatter, I have to do this laser engraver recipe, which looks quite painful. It uses super dense hot protohalconite steel, which needs a stabilized black hole, which is why I got around to fixing my black hole automation in the first place, and 10,000 seconds at UIV with some protomatter. That's fine. It's a wait, but it's fine. Secondly, I'm going to need some fluids. Tachyon-rich fluid, spatially enlarged fluid, molten Cherabon, all of which I have so far, and depleted Naquata fuel Mark 6. Depleted Mark 6 NAC fuel can be made in two ways. One is the neutron activator, and I'm starting to understand why this exists, this recipe, because it could take a while to burn the fuel, because it's 12 seconds for 1 liter. I mean, there's parallels and everything, but still. But the neutron activator processing speed, while it looks really slow, it's actually as fast as you make it, because the speed increases with the length or the height of the neutron activator. So this could, in theory, be done in 1 tick if I wanted. So I kind of get it now. I thought this was a silly recipe, but maybe it's not. For now, I will be using the large NAC reactor recipe because I could use the power, so why not? But that means I need Mark 6 NAC fuel. This is pretty chill. It needs molten Cherabon, Mark 5 fuel, tritanium dust, and astral titanium dust. So I'm going to quickly update my NAC fuel setup to start burning Mark 6 NAC fuel, build up a nice big backlog of depleted fuel, and also get some antimatter to get started. And by the way, antimatter is not at a temperature of -1 Kelvin. Antimatter temperature works the same as matter temperature, so that's kind of silly. Negative Kelvin, by the way, fun fact, is not impossible. It's just very specific systems have that. The most common example is a laser. It's a bit complex, and I'm not really the best person to explain thermodynamic stuff, but it makes sense. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will, without further delay, construct and automate the semi-stable antimatter stabilization sequencer. The black hole automation ended up being an effectively completely new solution, so its explanation went on for longer than initially anticipated. Anyway, please let me know if you have any feedback about the Large Hadron Collider idea. The design doc is linked in the description. See you next time.